There's a complicated way of describing DSD. It involves math and sigma delta modulators and all that, but at the end of the day, what really matters is whatever bit stream that when you low pass filter it gives you what you want is DSD. There's another way of looking at DSD, which you actually see inside a lot of Sony SACDs. They have a little insert that talks about pulse density modulation. What that means is when the signal's high, you have a lot of pulses that are high, and when the signal's low, you have the pulses that are low. But what if you draw a picture of it, you see dense pulses when the signal's high, and then when the signal's around zero, you see it pulse down, pulse up, pulse down, pulse up. It's the minimum density. And then when you get to a low signal, you see a whole lot of pulses that are down here. If you think about those pulses as units of energy, it sort of makes sense. You've got a high signal, you've got a lot of energy. Got a low signal, you've got a lot of energy down here. Zero is balanced energy, top and bottom. After you run it through a filter, you get out what you're putting in. If you look at a DSD on a graph, it looks a lot like your analog waveform if you just fuzz your eyes just a little bit. One of the misconceptions about DSD is that it's high rate PCM. But that's not quite true. In PCM, let's say if you have 16 bits, we all know that that's approximately 96 dB of signal to noise ratio, each bit being approximately 6 dB of signal to noise. But one bit gives you a whole 6 dB of signal to noise. That's garbage. But if you go really fast, you've got a lot of information to play with. So the trick is how to get the information you want in that really shallow band, and the trick is noise shaping. So if you filter it so that you're using a lot of dynamic range at the bottom, like in audio, we can go down, DSD is defined to give you a signal noise ratio of at least 120 dB from 0 to 20K. You can do better than that, but that's the minimum spec. What you're trading off is that you've got even less noise ratio up in the high frequencies. But you don't care. You're going to filter that out anyway. So the beauty of noise shaping is just to slosh a little extra precision wherever you want in the band and trade it off for less precision somewhere else. By oversampling enough times, you get that extra slop space to pull down and give you more signal to noise ratio on the bottom. This is not a new thing. There have been digital processing techniques, and even some that they put on CDs, they do use noise shaping to try to get a better signal to noise. And, I can't remember the name of them, but, you go up a little bit and you get a little bit better signal to noise with noise shaping. It's not a bad thing, it's not a weird thing. It's just different than people expect in PCM. Understanding all the trade-offs that are different between DSD and PCM is sometimes hard. In PCM, you have a certain code, your bits, your 16 bits tell you a number, and you have to translate that number into a level. To get that done very well, you've got to have very precise values for each one. You've got to make sure that every time you increment your number by 1, that your level changes appropriately. There are ways of doing this that don't require a very extremely precise power supply, because what you're really doing is the levels are set by all these little resistors. So if your power fluctuates just a little bit, it doesn't really make your signal turn inside out or anything like that, because if the thing is done right, every time you go up by 2, your sound's going to get 2 units louder. In DSD, the way I'm doing it, if you're going from one rail to another, if all of a sudden that rail sags a little bit, it becomes direct distortion. Now, DSD is wonderful in that it's inherently linear. If you want a level that's higher, it will always give you a level that's higher. The bits are just denser there, and you'll get a higher level. The difference between PCM and DSD isn't as big as most people think in some sense, because most of the DAC chips that are out there that people are using actually use something that's much closer to DSD on the inside than it is to PCM. And they used to market it as a PCM DAC, and people think of it as a PCM DAC, and people that are very proud that they only use PCM and that PCM is God's gift to earth and DSD is something from the devil, actually end up using DSD in a lot of their products. But that's not quite the same DSD as we're using. I talked earlier about little bitty chips have problems, inherent problems, and one of them is they don't really just take the bits and low-pass filter them. They can't get accurate capacitors and resistors and inductors, if they wish, to do the low-pass filtering in a chip, so they have to make some compromises. So one of the things that they do is, perhaps most accurately described, as do some digital low-pass filtering in the chip that gets them a little bit of the way from DSD to PCM. In other words, it's not 1 bit with noise shaping, it's say 4 bits with noise shaping. So they got to get 1 of 16 values accurate. That's not terribly hard in a chip. And then they've got to low-pass filter that on the output. But, well, when you do that, that's not quite good enough because caps are hard to get extremely precise to do a nice filter. And so they call it dynamic element matching and stuff like that. And its whole purpose is to sort of randomize out the errors that are there. So in some sense, these DAC chips are, jacks of all trades and master of none. Now, a lot of people now are putting DSD in their DACs because, well, they got this little chip that can do DSD. But it may not be the best PCM DAC chip in the world, and it's not the best DSD DAC chip in the world. It's cost effective, it works, you can buy a lot of them, and they sound pretty good. We tried to sidestep that by doing DSD exclusively. We sidestepped more than you might think because we actually are just low-pass filtering the bits. So we're avoiding dynamic element matching, we're avoiding constraints on how accurate our capacitors can be. We can get 2% film capacitors and put them in parallel to get better quality. Put everything in parallel, make it balanced, and all these things that you can't do in a little chip to make it sound better. So, although everybody and their dog is adding DSD, and I think that's wonderful actually, some people's new DSD DACs don't sound that much better in their PCM DACs because they're using something that was originally tailored to be an efficient way of converting PCM, which happened to be something like DSD. It isn't quite DSD, and when you hear real DSD, there is a difference.